I've had so many requests for doing data interpretation questions, particularly hard level ones. So I've gone on to greprepclub.com, link in the description, and I've gone for tagging the questions as hard. So all of these are marked as hard. And I'm just going to do as many as I can until my brain just melts. So let's just see how many I can get through. I'm just going to do one after another and check them as I go. So let's go for the first one here. 800 insects were weighed and the resulting measurements in milligrams are summarized in the box plot below. What are the range, the three quartiles, and the interquartile range of the measurements? The range is just the biggest one minus the smallest one. And using this graph, the biggest one looks like 146. The smallest one is 105. So you take those away, I think that's 41, and that would give you the range. The three quartiles are the three middle lines. So the first quartile here is 114, it looks like. The median, the second quartile, is 118, and the third quartile is 126. If the 80th percentile, this is the next question. Actually, I missed the interquartile range. So interquartile range is the third quartile, 126. Take away the first quartile, 114. That gives us 12 for the interquartile range. Part B. If the 80th percentile of the measurements is 130, how many measurements are between 126 and 130? Well, notice 126 milligrams is Q3, the third quartile. I've done a video on this, do check it out, on interquartile range and quartiles. But Q3, which is the 75th percentile, is 126. And they're telling us that the 80th percentile is 130, which means that we've got between 75% of people and 80% of people, that's 5% of, not people, insects. 5% of the insects are between 126 and 130. Just quickly again, 75th percentile is 126, 80th percentile is 130. That gives us a 5% gap between that range, and they're asking how many insects. Well, there's 800 in total, 5% of that is 40. That would be my answer here. They're saying medium, but it was tagged as a hard question. And I wonder if they give the range was 41. Those were the three quartiles. Interquartile range was 12. And then presumably they're going to say the 5%, that's 40. Obviously, I'm not going to look at all the explanations here in detail. That's just the answer there. And we've got the next question here. The graph shows the percent change, that question. Okay. The graph shows the percent change in the annual city tax revenue. The percent change in annual city tax revenue for 5 cities between 1990 to 1995 and from 95 to 2000. If the annual tax revenue in city B was 800,000 in 1990, what was the annual tax revenue in city B in 2000? So here's my calculator. Let's do this. So in city B in 1990 it was 800,000, and then it looks like it dropped 15% to get to 1995. So 800,000. I'm just going to do the 800 to drop down by 15%. We times it by 0.85. It's the quickest way to drop down by 15%. Remember, we can't do this all in one go. We're not going to amalgamate those two percentages. Now separately, we're going to increase that by 15%. To get from 1995 to 2000, because it said it went up by 15% between those 2 years. So now we times by 1.15 to increase by 15%. You should know that, giving us 782. Notice we don't get back to where we started, even though it might seem like it is. Okay, so that would be answer C, correct. Next one. Again, you can see that these are labeled hard. So I'm just going to do one after another. I keep going, as I say, until I get completely fatigued. Good time ourselves if we want. Number of people, number of movies seen. Okay, number of people, number of movies seen. Interesting. What's the difference between these though? I'm kind of curious. Can't quite see the difference, but anyway. In a survey, 130 people were asked how many movies they had seen in the preceding year. Their responses varied from 0 to 30. The graphs above show two different summaries of the same results. I see. How many people responded that they had seen 11 or 12 movies. 11 or 12 movies. Interesting. That is a hard one, actually. I think a lot of people would struggle with that. And you know the way that we're going to get it is by working from another part of the graph. Because it's really kind of confusing. We know that there are 30 people between 6 to 10. So what we do is we look at the first bar. And notice 0 to 5 is 25 people. 0 to 6 is 30 people. And that means there must have been 5 people who got a score of 6. 5 people with a score of 6. And using that for the second bar on the top graph, if there are 5 people with a score of 6 and there are 30 people with a score between 6 to 10, then if we take that away, that leaves 25 people with a score of 7 to 10. It's like we're using one bit of information to find another bit to find another bit. So just to recap, look at the left-hand side of the top graph. There are 25 people between 0 to 5. There are 30 people, if you look at the left-hand side of the bottom graph, between 0 to 6. That leaves 5 people who must have got seen 6 movies. Going up to the second from left on the top, there are 30 people who saw between 6 to 10. If we take away the 5 that saw 6 movies, that leaves 25 people who saw between 7 and 10. And finally, if we go down to the second from left on the bottom graph, if there are 25 people who saw between 7 and 10 and 35 people who saw between 7 and 12, we can subtract that to say that there must have been 10 people who saw between 11 and 12. So the answer is 10. That was pretty tough though. Pretty tough, that's correct. But you had to have quite a few steps, subtracting one graph from the other to see the difference multiple times. That was tricky. Let's do the fourth one. These are tagged as hard, so that's what I should be expecting here. Let's move on to this one. We have last week's total hours worked and hourly wages for the cashiers at Market X. Hourly wages and hours worked. These are quite low hourly wages for America. But anyway, last week, no more than 2 cashiers worked at any one time. No cashier worked for more than 12 hours on the same day. And on each day, each cashier worked continuously. Okay. If Market X is open 96 hours per week, for how many hours last week were 2 cashiers working at the same time? Now, if we add up the total hours worked, then we take away the total number of hours that they worked per week. The total number of hours that it was open per week. That would show you how much extra hours. So how many hours 2 people must have been working at the same time, the overlap. We know that it wasn't 3 at the same time because it says no more than 2 cashiers worked at the same time. So let's add that up. 40 plus 32, you can do this in our head, 72, plus 26, 98, plus 25, 123, plus 22, 145 total hours, but it was only open 96 hours per week. So 145 minus 96, what is that, 49 hours? So for 49 hours, 2 people must have been working at the same time. That's how the hours can add up to 145. But it was only open for 96 hours. So what was that again? I forgot the number, 49, 145, yes, 49, so A. That is, yes, A. Okay, that was pretty tough as well. So let's do the next one here. Okay, here is this question. Let's do the timer again for fun. Okay, the number of television sets sold by Store R last month. 3 types of electronic units in stock and sold by stores RS&T. Number of units in stock was this. Number of units sold as a percent of the number of units in stock. Okay, so Store R had 40 television sets in stock, and they sold, looking at television, that's 50% of them for store R. If you look at the graph on the right, they sold 50% of them. So they sold 20. And what about store T? Store T had 50 in stock. If you look at the graph on the left, the chart on the left, they had 50 in stock. And looking on the right, they sold 90% of them. 90% of 50 is 45. So they sold 45. And store R sold 20. Now, how do we work out 20 as a percentage less than 45? Well, you do the difference. That's the numerator. The difference between those two numbers is 25 divided by the original. And which one is the original? The original is the one that comes after the word than. People always forget that. So the gap between 20 and 45 is 25. That's the numerator. And the denominator is the 45, because that's the thing that came after the word than. So 20 over 45, 25 over 45, I would need a calculator for that, is 55.5, so 56%. Answer B. 1 minute 46, okay. I was explaining it a little bit, but yeah, answer B. Tough one. Couple of different mistakes you could make. If you just looked at the number of units in stock, you'd get it wrong. You've got to look at the percentage sold. And if you didn't know the percentage less than or greater than formula. I can predict with confidence that we're going to see this formula quite a few more times today, because it comes up a lot in data interpretation. Okay, let's do more of these. Which of the following can be inferred from the information? Here we go. Let's do the timer again for fun. I won't always do it, but let's give you an idea. Wow. Profile of Congress in year X, total membership 535, and then all different bits of information there. Which of the following can be inferred from the information given? Oh, it's one of those tick all that apply. It's going to be tough. Is it true that more than 80% of the men in Congress are members of the House of Representatives? How many men are there in total? Men in total. We've got 418 and 100. 418 in the House, 100 in the Senate. So that's 518 men. And out of 518 men, what's 80% of that? I'm not going to do that in my head. That's 414. And we've actually got 418 in the House. So it is more than 80% of them that are in the House. So that's a yes. The percent of members who are categorized as farmers or ranchers is greater for the House than for the Senate. Okay, so in the House, where's farmers? That's 14. 14 out of 435, because that's the total. If you look at the left in the House, 14 out of 435, what's that as a percent? Out of 435. That's 3.2% that are farmers or ranchers. And in the Senate, it's 6 out of 100, which is 6%. So it's not greater for the House, it's greater for the Senate as a percentage. So B is not true, A was true. The median age in the Senate is 57. So the Senate, there's 100 people. So we would need to look at halfway between the 50th and the 51st. It only tells us the youngest is 34, the oldest in the Senate is 80, and the average is 54. But it doesn't tell us the median. There's no way to work out the median here. We'd need to know all the individual numbers. So we can't work out the third one. So I would just say it's A only. Let's find out. 2 minutes 20, a bit long. I was slightly explaining it. Yes, so that one's in, that one's out, and that one's out. So that was correct. Great. Okay, let's keep going here. Let's do the next one. Where is that? Total enrollment in institutions of higher education. Okay. I'm not going to do the timer for this one. Let's just look at it. Total enrollment in higher education by control and type of institution. Ooh. Wow. That's kind of confusing. In 72 to 95, and it's going up and down. Public, private, public 2-year, private 2-year. This looks hard. Percentage distribution of total enrollment. percent. Oh, so you can see the percentages. Okay, I think I understand. If the total enrollment in institutions of higher education in 72 was 5 million, okay, approximately how many students were enrolled in private four-year institutions in 1995? Private four-year institutions. Okay, so let's look at the second graph. Private four-year, if you notice, was like 22% or so, looking at the second graph in 1972. So 22% of 5 million. I could probably do that in my head, but I'll just do it here. 22% of 5 million. I'll just do it of 5,000 just to save time. That's 1.1 million. So we know that there were 1.1 million private four-year students in 1972. And then if we look at this first graph, this is tough for a lot of people, I think. Private four-year, it starts off, this is an index chart. So you've got to look at where it starts. So private four-year starts at 80-ish and then ends in 95 at 118. So you've got to look at the percent increase. It started at 80 or 81 and ended at 118. So what's that as a percentage increase? Do 118 divided by 81. So it grew by 45%. Private four-year, to use an index chart, grew by 45%. And we know it started off at 1.1 million. So 1.1 million to grow by 45%, it would be 1.6 million, which is E. I did round a little bit, so let's see if that's right. E is the answer. That was tough. You might want to pause and see again how I did that, but they did the same thing. They worked out 22% of the original, got the original 72 number, then looked at the index to find the increase, which I think I was maybe a bit more accurate. I think it was closer to 1.6 than 1.65, but either way, that's how you do it. That was tough, definitely. Okay, let's do the next one. As I say, I'm going to keep going until I just completely run out of energy, because I know you guys like this stuff. Again, it says medium, but I think it's between medium and hard because all of them are tagged as hard. Okay, the number of passengers on 9 airline flights were these numbers. The standard deviation of these 9 numbers is approximately equal to 10.2. Okay, find the mean, median, mode, range, interquartile range. Okay, I might not do that for all of these questions, but let's get started. I'm probably going to need a OneNote here or a WordPad. Let's bring up WordPad. Here's my trusty WordPad that I'm going to use for notes. Putting these in order, we have 19, 21, 22, another 22. I'll check at the end if I've missed any. 28, 31, 33, 44, 50. Did I miss any? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that's all of them. Okay. The mean, I'm not going to do it, but what you'd do is you'd add them all up on a calculator and divide by 9. The median is the middle one, which is, if there's 9 numbers, that's the 5th one. So 28 is the median. The mode is the one that comes up the most often, and that would be 22 because it comes up twice. The range is the biggest, take away the smallest, 50, take away 19. And now the interquartile range, which a lot of people would struggle with. How do we do that? What you do for interquartile range is you find the median, which is 28, and then you look at the numbers to the right first of all. We're going to find Q3. So looking at those numbers on the right, 31, 33, 44, 50. Let's find the median of those numbers. To find the median, well, because there's 4 numbers, it's halfway between the 33 and the 44. So add those up, divide by 2. What is that? 77 divided by 2 is, could use a calculator, but 38.5. So 38.5, I'll just write this down, that's Q3. Okay, that's the upper quartile. Move it across. How do we find the lower quartile? Exact same thing, but on the left. So 28 is the median. So let's look at the numbers to the left of that. The median of that set would be halfway between 21 and 22, which is 21.5. So 21.5 is Q1. You see how I did that? Found the median on the left, the median on the right. Interquartile range, you take them away. So 38.5, take away 21.5 equals 17. So 17 is the interquartile range. And check I've done the maths right there. Yes, 17 is the interquartile range. Okay. If each flight had 3 times as many passengers, what would have been the mean median? Okay, so if we times by 3 for each of these numbers, the mean would get 3 times bigger. So whatever the mean was, times it by 3. The median would get 3 times bigger. So whatever the median was, I think it was 28, you times by 3 to get the new median. The mode, you times by 3, so it was 22 before, now it's 66. The range you would times by 3, so the range before was 50 take away 19, 31, times by 3 for the new range. Same thing for interquartile range, it gets times by 3. But I think what they're really testing is, do you know what would happen with the standard deviation? The standard deviation would actually also times by 3. It does change. So before it was 10.2, and now the new standard deviation would be 30.6. Okay, let's look at the next question. If each flight had 2 fewer passengers, what would have been the interquartile range and standard deviation? Now, the interquartile range would not change, right? Because the quarter 3 would have gone down by 2 to 36.5, but the quarter 1 would have also gone down by 2 to 19.5. So the interquartile range wouldn't change, and nor would the standard deviation. People think that subtracting or adding might affect the standard deviation. It actually doesn't. If you add 2 to all the numbers or take away 2 to all the numbers, it doesn't actually change the standard deviation at all. So neither of those would change. That was quite a long one, but I wonder if anyone's going to give the answer here. But I know that my answer was right here. Okay, so standard deviation doesn't change, it's the same. Interquartile range doesn't change, it's the same. That was quite a fun one. So let's keep going though. Hopefully you're enjoying this too. Okay, let's look at this one. Average weekly earnings of full-time workers, bachelor's, college, high school, etc. Educational attainment of full-time workers, this, in the different cities. Okay, Hannah attended some college and earned 20% more than the average person in her educational category. So some college is $750 if you look at the top chart, and she earns 20% more than that. Let's quickly work that out just using the calculator. $750, how do we increase by 20%? Times by 1.2. So she earns $900. Okay, good to know. After she earns her degree, she'll earn the average weekly salary for bachelor's degree holders, which was $1,200. So she's earning $900 now, and she's going to earn $1,200. Hannah will spend $6,000 in tuition and take a 50% pay cut for 30 weeks to earn the degree. Okay, so her current wage is $900, and so therefore it's going to drop to $450. After she gets her degree, for how many weeks will she need to work to recoup her lost wages and tuition using the extra money she will earn weekly? Okay, so the amount of money she lost, she took a 50% pay cut. So her $900 went to $450 for 30 weeks. So she lost out on $450 for 30 weeks. Oops, $450 for 30. I should use my keyboard, but I'm lazy. So she lost out on $13,500 in wages. She also lost out on $6,000 in tuition. So she spent $19,500. But remember, her wages went from $900 to $1,200. So she gets an extra $300 a week with her new wage. And notice we're focusing on the extra money, not the new money, just the extra, which is an extra $300. So if we divide by 300, we'll find out how many weeks with that extra money it will take to pay off all her costs. 65 weeks. Okay, let's check that. And yes, 65 weeks. Again, feel free to pause and check their explanations, but I'm confident in my methodology here. Let's keep going now with some more of these questions. Hopefully you're enjoying it. Please let me know and leave a comment if you are. Okay, I'll time this one now, again for fun. US population, the population on the left, the 10-year increase on the right. Okay, interesting. Okay, if the percent increase in population from 1910 to 1920, what was the percent increase in population? We could work that out. If that had been approximately the same as the percent increase from 1990 to 1910, okay, so we could work that out. The 10-year increase in millions would have been what? So if it used the percent increase from 1990 to 1910, what was that increase? Well, we went from 76 to 92. What is that as a percent increase? Wrong tab. We went from 76 to 92. Bring up my calculator here. So we do 92 divided by 76 is the quickest way to find the percent increase. That was a 21% increase between those 2 years. And they're saying if that percent increase from 1910 to 1920 had been the same, so if that had also increased by 21%, so in 1910 we were at 92, and if that had increased by 21%, we had gotten to 111. The increase in population would have been what? So it would have been at 111, which was, if we take away 92, that would have been an increase of 19.32 million. Answer D. Okay, so they will explain it hopefully somewhere. Yes, 19 million. Okay, not too bad. You just had to read and understand the question, which is what all these examples are for, really. Oh, I didn't pause the clock. Probably about 2 minutes for that one. They wanted you to work out the increase from 1900 to 1910 and then use that percent increase from 1910 to 1920 and see what the growth would have been. Okay, where's the next one? This one, increase in tuition per student. Let's time this one again for a laugh. Enrollment, faculty size, faculty salary, and tuition at college are for selected years. So that's the students in 1960, 1490, number of faculty members, etc., ratio, tuition, etc. The increase in tuition per student from 1970 to 1980, so that's from 2,000 to 3,700, was approximately how many times as great as the increase from 1960 to 1970? It's a rather easy question. So the increase there was 1,700 from 1970 to 1980. And the increase from 60 to 70 was 600. So 1,700 is how many times bigger than 600? Seems a bit too easy to me. 2.8. It's about 2.5 times. Why is that? I guess it is approximately, so it's 2.5, but they didn't say percent increase. They just said the increase in tuition. So that was the increase, $1,700 per student. Okay, seems a bit easy to me. Did I get it right? And it is, where's the answer? Hopefully here, 2.83. Yeah, that's the answer, right? Fairly weird one there, fairly easy, but as you can see, the difficulty is tagged as hard, so just can answer the questions in front of me, but let's do this next one. Hopefully it's a bit harder. Okay, this one looks kind of fun. Median home prices in the US by selected region. Percent increase in home prices, 83 to 86. And then northeastern cities as well. Okay, quite complicated, but anyway. In 1986, for which of the cities listed was the median home price minus the median down payment the greatest? Well, to work out the median home price, we would have to get these original numbers. Oh no, these are cities. So forget that. Not using the top one, using the bottom one. Median home price and related data. Okay, so these are the median home prices on the left. Okay, and that is 1986. So New York, for example, was 129,000. Was the median home price minus the median down payment the greatest? Just taking those away. I guess they're testing if you can do that in your head. So like 130,000 take away 42 is about 90,000-ish. But then for Boston, it's higher because if you take 30,000 from 126, you get about 96,000. So Boston is higher. I guess they're testing if you can do it quickly. Newark looks lower because 116 take away 30 is lower than 96. Danbury is definitely lower. So it's going to be Boston because even though New York had a higher median home price, it's a greater down payment. So the difference was lower. The difference was about 90,000. But for Boston, if you take them away, you get about 96,000 or so. Maybe just an example of how you can answer some questions in your head. And I didn't time it, but it's fairly quick. So Boston is correct. You can do that without a calculator in your head. Quite a good example, actually. Okay, pharmaceutical division. So the question here is, let's time it for fun. Pharmaceutical division expenses, I've got a load of numbers. Chemical division expenses, a load of numbers. The pharmaceutical division's interest on debt. Pharmaceutical interest on debt, that's 2%. We don't know the total. Is 4 times that of chemical division, which is 2%. So this one on the top is 2%. This one on the bottom is 2%, but they're saying the pharmaceutical is 4 times bigger, meaning the pie must be 4 times greater, 4 times larger in size. For example, $400 for a total here, 2% of that is 4 times bigger than 2% of $100. Otherwise, how can it be 4 times bigger with the same percentage? Okay, what percent of the chemical division's payroll expense, which is 38%, is the pharmaceutical division's payroll expense? It's 26%. To be honest, I'm just going to use those numbers I just made up because otherwise this is going to get confusing. The chemical division's payroll expense, that's 38% of 100. That's $38. And the pharmaceutical division's payroll expense is 26%, and I made up the total to be 400. So 26% of 400, I could do this in my head, but I'm going to be lazy again. That's 104. So those are the two numbers. We've got 38 and 104. What's the question? What percent of the chemical division's payroll expense, 38, is the pharmaceutical division's payroll expense, 104? So interesting, when you have a percent of question, the thing that comes after the percent of is the denominator. So what percent of this, which is 38, is the numerator pharmaceutical, which is 104? People get it confused. So what percent of 20 is 10? 20 is in the denominator, 10 is in the numerator. So what percent of chemical, 38, is pharmaceutical? It's pharmaceutical on top. So 104 divided by 38, which is 274%. Answer E. That was a really tough one and a really good one to do, actually. So you may want to rewatch that. Obviously, I probably took a bit too long, 2 minutes 40, but obviously I was explaining it a little bit. But that was a really fun one, a really good one to do. So do check that one out yourself. But let's move on now to this one. Actually, I didn't check the answer, but I'm pretty sure that's correct. Answer is E, yes. Okay, this next one. Okay, shall I time it? Why not? Let's do it. Okay. Distribution of financial assets held by households in country W by asset category in 1990, 1998. Bank accounts, bonds, etc., etc. Okay, all others indicates all financial assets not included. Okay. Of the amount of household financial assets in the 6 major asset categories in 1990, approximately what fraction was in bank accounts? Of the amount of household financial assets in the 6 major ones. So we've got to be careful. We're only counting out of these. What fraction was bank accounts? So yes, bank accounts was 19%, and some people will just convert that to a percentage or to a fraction, but it's out of the 6 major asset categories, which is these first 6. So it's like 19 in 1990 out of these 6 added, which are 19, if you're looking at the yellow, bonds was about 12, and certificates was about 10, and mutual funds was about 5, and retirement was about 22, rounding here obviously, and we've got stocks of 15. So even though you might think it's out of 100, it's actually 19 out of 83, because we're only comparing it to those 6 major categories, not the all others. Because it said out of the 6 major asset categories. So out of the 83, what fraction is bank accounts, which was the 19. So it's 19 out of 83, which that's about 1 in 4, isn't it? 23%, it's about 1 in 4. Yeah, roughly 1 in 4, so answer C. Really fun, really interesting. Let's see if I got that. I'm pretty sure that's right, yeah. 23%, which is about a quarter. Because notice it's 19 out of 84, not 19 out of 100, which is 1/5. Really important. The denominator wasn't 100. The denominator was the 6 major asset categories, which added up to 83 in my book. Really easy to make a mistake on that one. I'm really glad we did that example. Oof, this is tough. Getting fatigued now. So many data interpretation questions. But let's do another one. I'm doing this for you guys. I'm sacrificing for you. So please do leave a like or a comment. Let's time it. Why not? Motor vehicle theft in the US, percent change from 94 to 98. Number of offences known and the rate. Okay, so it's seeing the percent change that went down quite a lot, both in the rate and the number of offences. By what percent did the number of vehicles stolen decrease from 97 to 98? So let's just give an original figure of 100. Otherwise this is going to get confusing. So if we started on 100 in 94, in 1997, we're looking at the number of offences. So that's a square one. It went down 12%. So in 97, we're at 88 thefts. In 98, we're at 81 thefts using 19%. So we went from 88 thefts to 80.6 thefts using 100 as the starting point. Just pick numbers there, obviously. And so what percent decrease is that from we ended up at 80.6 and we started at 88. So that's a percent decrease of about 8.5%, which is answer C. Maybe you guys would have a different way of doing that. But for me, just picking a number for the, stop the timer, picking a number for the start, like 100, it just made it easy to compare the two figures. You can't just look at 12 and look at 19.4 and say, oh, that's a gap of 7.4%. It doesn't work like that. You have to, I think, pick a number, work out the two answers, and then compare them. So that was an interesting one and quite a tough one. And let's check if that's right. Yes, it is right. So that's fine. This is definitely a workout, but I really hope it's helping you guys. Okay, let's do this one. No timer here. That makes it a bit easier for me. A family's expenditures and savings as a percent of its gross annual income. So we've got income tax, mortgage, etc. 2003, 2004. Gross annual income 50. Gross annual income was 45 in 2004. Okay, A. In 2003, the family used a total of 49% of its gross annual income for 2 of the categories listed. What was the total amount of the family's income used for those same categories? So 49%, that's roughly 50% of 2003, so that's $25,000. What 2 categories did they spend $25,000? Or we could just look at the chart actually. 2003, where did it add up to 49? In 2003, it's the black one. This income tax was 31. Was there another one that added on 18 to get to 49? Where's 18? No, there was no black bar that's 18, so it can't have been income tax. Let's check mortgage. Mortgage is 24. What does that leave to get to 49? It leaves 25, but there's no category. Actually, there is this category, savings, that's 25. So mortgage plus savings adds up to 49 because it's 24 plus 25. Okay, so we know that they're talking about mortgage and savings. And what was the total amount of the family's income used for those categories in 2004? Well, mortgage was 27 in 2004. Savings were 12 in 2004. 12 plus 27 is 39. That's 39%, answer A. That was a tough one. You had to see which ones added up to 49. I didn't actually use the $25,000 in the end. Okay, of the 7 categories listed, which category of expenditure had the greatest percent increase? So we're looking for the bar to jump the most as a proportion of the original. So if you look at the second one, mortgage, you might think that's the biggest jump because it goes up 3, or food, it's the biggest jump because it goes up like 4 or something. But we're looking for it as a percentage. So it's miscellaneous, definitely, because look, it like tripled, more than tripled. So as a percentage, it was like a 300% increase. So even though another bar might have been a bigger jump, for example, I don't know, maybe food looks like a bigger jump, but this is by far the biggest percent increase, was miscellaneous. Okay, so let's check those answers. Does it answer? Yes, it was mortgage and savings, and that added up to 39%. And yes, it was miscellaneous, which tripled. Again, quite a tough one, but a fun one to do. Okay, imports. I've got the question here, and I'm going to do the timer for this one for a laugh. The value of imports to and exports from country T 2000 to 2009 in US dollars. Exports is the thick line, imports is the dotted line. 1 billion is 1 billion, okay, cool. If it were discovered that the value of imports shown for 2007, that is $7 billion, this is in billions of dollars, was incorrect and should have been 5 billion instead. Interesting. So it was 2 billion overestimate. It said 7, it's actually 5. Then the average arithmetic mean value of the imports per year for the 10 years shown, the average over 10 years, would have been approximately how much less? I'm actually so glad that this came up because many of you would actually calculate the average. You'd do each of these dots on the dotted line, add them up, divide by 10, find the average, then find the new average and then compare them. But actually think about it. We know they made a mistake of 2 billion. They wrote down 7 and it's actually 5. So they made a mistake of 2 billion. And that mistake is distributed across an average of 10 years. So if we do 2 billion divided by 10, which is 200 million, that's the mistake. That's the impact on the average across 10 years. If we're just talking about 1 year, it's just a 2 billion mistake. But affecting an average of 10 years, that's a 200 million mistake per year. So we don't have to actually calculate the two averages and compare them. We just know it's a $200 million approximate error if we're looking at a 10-year average. Stop the timer. And where's the answer? Yes, it was 200 million. But that was a really fun one. I'm really glad that came up. So let's do the next one. Store X, shelf 1. Here we go. Start the timer. Average weekly sales and shelf space in Store X for products from 5 bakeries. All of that. Oh, this looks really complicated. Distribution of shelf space. Okay, whatever. In Store X, shelf 1 accounted for a quarter of the bakery's average weekly sales. And shelf 2 accounted for 2/3 as much as shelf 1. Okay, if shelves 3 and 4 each accounted for less than shelf 2, but together accounted for more than shelf 1, then which of the following could have been the average weekly sales of shelf 5 for bakery C? My goodness. Shelf 1 accounted for a quarter of the sales. Shelf 1 accounted for a quarter of bakery C. So their weekly sales was 300, so a quarter of that is 75. And so shelf 1 was 75. Shelf 2 accounted for 2/3 as much, which is 50. Shelves 3 and 4 each accounted for less than shelf 2, so each of them were less than 50, but together accounted for more than shelf 1, so more than 75. So together it was more than 75, but each of them was less than 50. Which of the following could have been the average weekly sales of shelf 5? Well, the total is 300. Let's bring up WordPad. We know that one guy, the first guy, was 75. The second guy was 50. And the other two add up to less than 75. Sorry, they add up to, what did it say? Shelf 3 and 4 each accounted for less than 50, but together for more than 75. What two numbers add up to more than 75, but each one of them is less than 50? Like 40-40 maybe? Something like that. That's more than 75, but each of them is less than 50. Which of the following could have been the average weekly sales for shelf 5? Adds up to 300, so what's left over? So far that's 125 plus 80, that's 205. So it could be like 95 as the last one. Let's test if it could have been, we're going to have to test the answers actually. So let's test the closest one, which is D. Could it have been 110? If it was 110, we actually don't know these middle two. So if it was 110, 75 plus 50 is 125 plus 110, that's 235. That leaves 75 left over. But we know that these two add up to more than 75, so it can't be 110. Let's try 80. If it's 80, that adds up to 205. That leaves 95 left over. Divide by 2, it does work. 47.5. That's still less than 50 and it adds up to more than 75. So it's answer C. Really tough though, ridiculously tough. Yeah, 3 minutes. I'm not surprised. You really have to go faster on the other ones to maybe get that right. That is so tough. In the end, I kind of just checked answers. And I'm sure there was a better way of doing it. But yes, it was option C, just by picking numbers. Really tough though, really tough. Let's end on a nicer one than that. Okay, let's do a couple more. Let's see this one. Okay, complaints received. Let's time it again. Consumer complaints received by the Civil Aeronautics Board. Got percentages, blah, 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 1980, 1981. Total number of complaints. If the categories except other are ranked by percent of complaints from greatest to least, okay, they are already, aren't they? For how many of the categories would the rank change from 1980 to 1981? Okay, so they're in order for the first one I see, but they're not in order for the second one. So flight problems did stay first, baggage did stay second, but customer service changed because that's not third anymore. 11.3 is not third on the right. So customer service changed. Oversales, that was fourth, but now it's not, now it's third. So that changed, that's 2 that changed. Refund was fifth. 8.1, is that different? No, I think that's still fifth, right? Just the order of 3 and 4 switched, but otherwise it's still fifth. So far 2. Fares is 6, but it's still 6. Reservations is 7th, but it's still 7th. Tours is next, but it wouldn't be next. These two would flip. Tours and smoking would flip because it's the smoking overtook the tours in complaints. So that's third one and fourth one that changed. Advertising stayed the same. And credit and special passengers flipped because it was credit then special, but now it's special then credit. So they flipped as well. So that's fifth and sixth one that changed. So I think 6 changed. Did I miss one here? I don't think advertising changed in position, no. Okay, I would go with 6. Tough one though. And I'm only about 90% sure. So yes, 6 categories changed. Pretty tough one. You had to just see that when 2 flipped, like customer service and oversales, when they flipped, it used to be third and fourth, and now it's fourth and third. That counts as 2 categories shifting, and there are 3 of those shifts. Pretty tough one though. Let's really try and end on a slightly nicer one. Okay, let's look at this one. Oh, let's put a chart here. I've got to get rid of that, and then we can do the question. Okay, what's the question? For how many of the years shown did the ratings for program Y increase over the ratings for program Y the previous year? Program Y is the dotted line, so increased in 81, increased again in 82, and again and again. And so that's 1, 2, 3, 4 years of increase, and then didn't increase again, so that's 4 years. So answer A is 4 years. Second question. In 1995, there were 95 million television households in the US. If in 1983 there were 80% of the number of television households, what's 80% of 95? 0.8 times 95. So if there were 76, they're saying there were 76 in 1983. Then approximately how many television households viewed program Y in 83? So program Y in 83 was 13. Ratings equal the percent of television households in the US that viewed the program. So 13% of those households viewed the program. So we know there were 76 million people in total, and 13% of them viewed that program, which gives us 9.88 million people who watched it. So that's 10 million, E. Okay, and the last one, if there were 20 million television households in 1983, then the number of viewers of program X is what percent greater than the number of viewers of program Y? Okay, we don't actually need to know the total if we know the 2 percentages. This is a nice little shortcut. So in 1983, X was 15.5%, and program Y was in 1983 13%. Now I know we could work out those 2 percentages of 20, or given the question is what percent greater, we could just literally use the 2% figures without even knowing the actual numbers. So 15.5 is what percent greater than 13? Just divide them. It's 19% greater. We didn't even need to know what the actual numbers were. So that was a really elegant one to end on actually. So 19.23 was the answer. That was E. And apparently there's a typo, but no, there was not a typo. It was correct. It was those 4 years, answer C. But that last one was a really elegant one to end on actually, because sometimes you don't actually need to work out the actual numbers. You can just use the percentages. I really hope this ultimate collection and drill example set was helpful to you. Please do let me know. Pretty exhausted right now, but hopefully you've got some good practice on hard level data interpretation questions.